Hi everyone, welcome to my channel Code with Ease by Varsha. This is day 3 of the tricky backend developer interview series that we are doing. Now, the sole objective of this series is not just to give you the interview questions which is asked in these kind of interviews, but also to potentially talk about the concepts which you need to understand as a backend developer and retain that for a really long time so that you can actually apply it in your day-to-day job. So which is the reason why I always mention these terms like like jargon free or layman terms, so that you can understand the concept, internalize and absorb the concept and retain it for a longer time. That is the only objective I have. I don't want to give you just a cheat sheet and that you will learn and mug it up and go for your interview, crack your interview, and then you will forget. When I say questions like how to debug this, how to troubleshoot it, this is something which happens in real world. I actually mean it. I want you to understand it and retain it for a long time. So that is one reason why I do this. So that is the reason why I'm doing this series. The second thing which I want to talk about is I got a comment that please share the notes, PPT, everything, whatever it is on GitHub. It will not take me much to do it. And it is something which I've done with other videos also. I've shared many notes on like GitHub documentation and everything, wherever I thought it is going to be useful. In this particular series, I don't think this is going to be useful. Please come with a notebook and a pen. I'm not being harsh, I'm not being rude. I'm going to tell you the reason why I'm saying this. First of all, notes that I give, that is based on my understanding. Notes are always very personal. That is based on no matter how layman I'll write it, it is always going to be for me. Notes that you make for yourself, for your understanding is always much better and more effective. Please understand this. I'm not telling this for myself. I'm telling this for you guys. You need to sit and interact with the video, understand a topic, take a note of it, pause the video, read about it, read maybe some other resources if you're not understanding it, and then again replay the video and again try to understand what I'm saying. In that way, make it more interactive, like a conversation. Don't think it is a dull and boring college school lecture where you just have to sit in front of the computer and look at the slides and the screen, and then once it is done, you will see the notes. Okay, and keep it. And once before going for the interview, you'll take the notes, mug up the questions. Nothing is shortcut in life, guys. There is no shortcut. You need to put in hard work. Only then you will be able to retain the concepts. Why do you think you need to only learn these questions just for this moment, just for the interview? No, you need to learn these concepts forever. The reason I have also retained it because I have made a lot of notes and I still make notes as of date. I have 6 years of experience, I still make notes. So that is a good practice which I want you guys to inculcate, because it will not take much time for me to make the notes and give it to you. But there is no shortcut, and that is not how software engineering works. You have to find answers to the questions on your own. There is no spoon feeding, there is no mugging up. So please get into that groove before you actually land up a job after cracking the interview. That is my message for all of you. Please come with a notebook and pen and interact with the video while you binge watch this series. Okay, so with that, we are starting the questions now. First question is, what is illegal monitor state exception? So the interviewer wants to know whether you know about this exception. They maybe ask you that in which scenarios does this exception occur. So basically they want to know whether you have knowledge about the multi-threaded context in which this exception occurs. So very simply, there are two reasons, two scenarios in which this occurs. So that is what I'll try to cover now. So if you are very new to threads and concurrency, want to revisit, I have a playlist dedicatedly for this on my channel. So you can check that out first and maybe come to revise the questions on Java threads and concurrency. But since this is a backend Java developer kind of a video in which we should be having all the topics which a backend developer should know. So threads and concurrency is a must-have topic, right? That is why I've included these questions also. So coming back to this, so why does this exception occur? The first reason is a very simple reason, that you are trying to call wait notify all method. They are not holding a lock on that resource and you're calling it outside of the synchronized context. So for example, if you see this code, I'm doing this lock.wait. Now I'm doing this inside a try catch. So I'm doing this inside a try catch, but I'm not doing it inside in a synchronized context, which means I'm not calling this inside a synchronized method or a block, which means that I'm not holding a lock on that object on which I'm calling the wait method. So without holding a lock, I cannot call a wait method or a notify method or notify all method, right? So for doing that, you have to write the code like this. This is the right way of writing the code. This is one fix that you can do to solve this issue. The second reason what can happen, it's a little confusing, that you are trying to hold the lock on one object. On the other hand, you're trying to call the wait on notify on some other object. So this is also very contrasting and like conflicting situation. So that you shouldn't be doing. That you're doing a synchronized on lock one, and then now by the first glance, it will look like, hey, this is something nobody would do. But what happens is when you write a long, really lengthy code and there's a lot of complex scenarios, this happens by mistake. This happens. So that is the reason you have to understand that if I am doing a synchronized on lock one, I will always do lock one dot wait. This is a very generalized and a very simple example to explain you guys about why this exception occurs, in which scenarios it occurs, so that you can understand how to answer this question. Okay, so here is another interesting question. What is the difference between class not found exception and no class def error? So it's a very common question, not because of the confusing names, but because it's a very relatable and something which happens in daily lives. Like when you're coding, there's something which can happen, almost daily. So you have to have real life debugging skills to solve this, right? And you have to understand this why it happens. Only then you'll be able to solve it. So that is the thing. So I've started with, so given a very cool analogy over here, class not found is you are trying to reach your friend whose address is not available in the address book. Like in those days, long back, we used to have address book. So let's say that contact information, or the one you have never met, that person's address is not available in the address book, and you're trying to find it out. So if it is not available in the address book and you're trying to find, so you will not be able to find that particular friend's contact, right? But no class def error is you know this person because you have met before, but somehow their address is deleted from the address book. There is just missing, like a missing friend, for example. So that is the no class def found error. So this is the biggest difference between these two. One, you knew before the address was there, but now when you need it, now the address is not there. And for another one, you didn't even know the friend and you never had the address also. So now, and this is more serious, no class def found error. So we'll come to that. So class not found is, so when you run a Java program, now coming to technical terms, your JVM will load the classes into the memory because it has to execute the program. And now it is not able to find the class which it is trying to load. So like the third party libraries, they are missing. So they are not able to load. The JVM is not able to load. And class path is a parameter which will tell, like the address book analogy is fitting over here, that it is going to tell from where the classes needs to be loaded, right? But it is trying to find through all these three methods, but it is still not able to find it in the class path. So what it is going to do? Okay, maybe the class path is not set up correctly. It is not able to, from wherever it has to retrieve the classes, that particular class path is itself not set correctly. Like the required classes it is not having, it is getting overridden somehow. That could be one reason. There can be typos in the name of the class. That is also possible. Or it is also possible that that class depends on another class and that dependent class itself is not available in the class path. This is also very commonly seen scenario, right? So also sometimes using different versions of the library version mismatch can also happen. So these two are the most common reasons when a class not found exception occurs. And also sometimes typos when you're hard coding it by writing class.font name and writing the package name. Sometimes wrong class name, wrong package name. Or also one more thing is the jar in which the class is there. You have seen that the jar, you have assumed that jar is in this package, but actually it is in some other jar. And this happens in big scale production systems also, where similar looking class names and similar looking jar or the library names are actually confusing. And you think that it is over there, but you later on like discover in the runtime that the class never belonged to that jar. So these are some of the reasons why it can happen. Right? So what is the solution? So first of all, you have to find out whether the jar file in which your class is supposed to be there, that jar file, is it actually available in the class path or not? Right? So you have to check whether that jar is there on the class path. And also you have to check if the jar is already on that class path, is the class path not getting overridden, something wrong with the class path. And of course, apart from that, the above reasons like we discussed. But somehow you will be always be able to resolve this class not found exception in a way. But no class def error is little serious and little tricky to understand. So we'll now go to this. So no class def found error is occurring when the JVM has done the compilation. It was available. So if you want to simulate this, you can do like the class file got generated. Okay, you compiled the code, the class file got generated, but now you remove the class file. The moment you remove the class file and run the application, you will see that it will give you no class def found. You can try this out in your IDE. So why is the reason? So the underlying reason is now during compilation, your class files were there. Okay. I mean, compilation happened and your class files got generated. So that was there. Now, when you're trying to run out of 5 class files, 4 of them are there, 1 of them is missing. So because of this, you are getting no class def found there. Okay. So this class got removed or becomes unavailable, like the example we gave of the friend's address. Why it happens? Now, why is happened? So class was available at the compile time, missing dependency. Sometimes it also happens due to the Maven, the dependency scopes. You give scope as compile or you give scope as runtime, right? Class file may have been removed, renamed, or corrupted. Again, possible. That is possible. So that's why I told you this example of try to remove the class file or maybe rename the class file. And the class could not be initialized due to some static initializer failure. Okay, this is also possible. So there can be many different possibilities, and in big scale applications, it is having hundreds of dependencies. It is technically very challenging to figure it out. That is why your basic should be very strong. So now ensure that your classes and dependencies are available. This. Okay, and there shouldn't be any issues like this. Incomplete builds or your deployment is not complete. That is there. Now try to understand couple of things very carefully. When you're compiling, okay, you have to ensure your build tool will have access to all the necessary jar files. Okay, and let's say you might have added a jar, but that jar is not available when the application got deployed. You use a Docker container, for example, to deploy it, and you didn't actually include that jar file in that due to some reason. That is one possible thing. Partial or incomplete build, in that is also possible that your build got failed. Okay, and it is very much possible in a multi-module project. Okay, wherein it tries to compile it locally, but in the final build you are not having those classes. Conflicting jars. So this is something which even I have faced when due to dependency conflicts, like one class depending on another class, and there's a version mismatch. Not a version mismatch, so to say, but it is like you have multiple versions. Okay, 2.3.1 is also there, 2.3.4 is also there. So one version getting loaded in the compile time, but in the runtime, some other version is getting loaded. So that is the wrong version of a class getting loaded is one of the very commonly seen thing in my experience of having this no class def found error, right? So for that, you should be using the Maven dependency tree command to find the conflicting jars. And corrupt jar files, you cannot really do anything about this. So you just have to re-download it from wherever you are downloading the jar files from. Right. So yeah, that is about this. So these are the things which you can take care of when you are getting these examples, issues, exceptions, and errors. So, and this is how you cannot be answering so many things, but try to understand the gist of the matter and just answer accordingly. This is a very interesting question. You will be asked that give a few reasons. Why are you using Spring Boot and why are you not using the Spring framework? What is the reason why you're developing your application in Spring Boot? And you have to see, I am trying to explain this thing to you in the most jargon free way. I can use difficult terms. But the point is, if you give difficult terms to the interviewer is also going to ask you difficult questions. So you have to learn to answer the every question in a plain, simple layman language, as if you are explaining it to a child. Only then you will be able to successfully clear the interviews. So now for this question, if you say it is opinionated, if you say it has auto configuration, sensible defaults, of course these are the keywords which you should know the meaning of. But don't use these terms much. You can say instead that Spring Boot is more developer friendly. It helps me to develop my applications faster, rapidly. Because the most commonly used components in the frameworks which I'm using, I don't have to manually define those. I don't have to write the logic for those, right? It is automatically available to me. So I can focus more on writing the business logic than worrying about the infra setup. So when I'm including the Spring Data JP, I'm not writing the data source bean. I'm not writing the entity manager. Of course, if I need to override it, I'll do it. But just for writing a simple Hello World web application, I don't have to sit and write these. When I'm using Spring Web Starter dependency, I don't have to set up any server. The Tomcat server, underlying embedded server, is already ready for me so that I can just do a HTTP request. So this is the thing which is making it developer friendly. And this is one of the reasons why I'm preferring Spring Boot over Spring Framework. Secondly, you can say, like, you can just pause and read about this. I've written, whatever I'm telling you, I've written a bit in detail over here. Like in Spring Framework, you have to manually define each bean, dependencies, XML based. everything, which is time consuming, wasting your time, right? So it is, instead of overwhelming the developers, Spring Boot is giving to us everything ready in a plate. That is one thing. Then we have Lombok, reducing the boilerplate code. Why will I sit and write the getter setter method? Okay, when I can use a simple annotation. Now, this is the beauty of using this annotation, which is not available over there. Then embedded server point, we have already told, I don't have to set up any server. If I just want to run it on localhost, I can run it happily because it gives me the embedded web server, and I can change the embedded web server also to my own wish. And the third thing is the starter dependencies. Will I have to sit and write every single dependency? When I say starter web, when I'm saying starter JPA, when I'm saying starter Kafka, I'm getting all the dependencies within that. I don't have to manually sit and write about every dependency which I have to write in Spring Framework. People who have worked on Spring MVC will be knowing this. So these are the things in which this is the way in which you should be trying to answer it. Giving examples, giving contrasting examples, points. So this is how you should be talking about this question. Next question, explain ORM in a very simple language. What do you understand about ORM? Okay. So full form of ORM is object relational mapping. As the name suggests, we are mapping a relational table to an object. Why? Because I want to interact with my DB using like my programming languages instances of the objects which I'm using. Instead of I writing the SQL query myself, I will create a certain method in my code, and that method will be written in a way that it is going to map that to its corresponding SQL query. So instead of me, when I'm sitting to write Java code, why will I write the SQL query? So I will write Java code only. So my language will be Java code. That should be doing the mapping to the relevant SQL query. That is the entire concept of using ORM. So in relational database, we are storing tables, and in object oriented, like the two data structures are completely different. So now ORM is bridging this gap by mapping your code, like the objects in the code, to the rows or values in the tables in the database, right? So mapping the tables to objects and the rows to the individual objects, right? You can work with objects and blah blah, all of that. So now if you see this particular example, you have a person table. Okay, these are the three things. Now when I'm saying select star from person where ID equal to 1, this is a standard SQL query. I'm not going to write this. I'm going to write like this: person repository dot find by, and then I'm going to pass in find by what? ID. So if I'm finding by ID, I'll do it. If I'm finding by name, I'll pass the name. If I'm doing find by age, I'll do that. If I do find by name and ID, then it means where ID equal to this and name equal to this. Plain and simple. So that is what I'm trying to do over here. That is the mapping which is happening. Okay, find by ID getting mapped to this actual SQL query. So in that way, I'm converting my code. I am not converting my code. The ORM tool is actually converting it. So what are the benefits? I am not using an SQL. Of course, it is not meaning that you don't have to know about SQL. If you do not know, you will not be able to write the actual method also over here, because it is not as simple as only find by ID. There are many different methods which we can write to do the relevant or the necessary SQL mapping. Automatic table management, of course, cleaner code. So there are many tools. We have Hibernate in Java, Entity Framework in .NET, Django, RN in Python, all of that. Fine. So just to give you an overview that ORM is not specific to only Java and Spring Boot, right? It is also available in other languages. But the point is, why do we need it? This particular code example should be able to explain that to you, and you should be able to explain that to your interviewer also. Next question is, what is the difference between a synchronized collection and a concurrent collection? Similar, both used in the multi-threaded context, but which one to use both? Okay, so now in case of synchronized collections, how we used to use this? In the collections clause, we had this method, specific methods, synchronized list, synchronized map. Okay, and this is how we used to do it. So if I'm trying to synchronize the access of the threads to this particular list, I'm going to use like this. Okay, how it works, the entire collection is locked at the method level, which means if it is a list, then every method of list, add, remove, okay, contains, all these methods will be like, whenever the thread is going to access, there should be only one thread who will be able to access this entire collection. Only one thread. But that is not the efficient or the most optimal way. We should be able to give access to more threads also, increase the performance also, ensure the data consistency also. So because of this, the performance lag is there. The performance will be very slow. Only one thread will access the collection at a time. Okay. So now that is leading to, of course, slow performance. These are the different examples. Now, on the other hand, concurrent collection came from java.util. Now, see the difference. This synchronized methods were coming from the collections utility class. Now, concurrent collections came in from java.util.concurrent package. Why? To increase the performance. How? By doing granular locking. I have a very detailed playlist on threads and concurrency, Java threads and concurrency on my channel. Okay. So many people follow that also. So if you need to know everything and anything about threads and concurrency, I would recommend you to follow that playlist as well, apart from this particular series. Okay. Now, there are many different concurrent collections. So I've covered about concurrent hash map, copy on write, array list also. So now how do they work? How do they work? So it will not log the entire collection. It will not log the entire collection. So when I'm doing an add method to the list and the list is entirely blocked in case of synchronized collection, but here it will only log a segment which is getting updated, only that particular segment. So which means that if the collection has 100 elements, I'm not telling that only one thread will be able to now work on these 100 elements. I will not allow any other thread to work on this 100 elements. It should not be like that. It will divide it into smaller segments or buckets. So I will, let's say, I will only work on the 5 elements, for example. Other 95 elements are open for other threads to be manipulating it. So that is the entire thinking, like thought process behind having a concurrent collection, right? So we don't have to lock the entire collection. So these collections will perform obviously better in highly concurrent situation, and because the threads can do granular level locking on different segments without waiting for each other. These are the different examples. So just to summarize on, you can just pause and read about it. What is the difference between synchronous collection and concurrent collection? What is the purpose? Next question. What is the purpose of enable @enable auto configuration annotation, and how does Spring Boot achieve auto configuration? If you want to exclude a dependency from auto configuration, what steps will I be taking? Okay. First, again, auto configuration I have just now covered in the previous question, what it means. At the sensible defaults, the opinionated framework, all of that. So auto configuration gives us, or maybe auto configures a preset, like a set of whatever dependencies I need without me manually configuring those. That is why I'm saying automatic configuration, auto configuration. So that my development will be faster, right? I gave the example of Spring Data JPA and the web dependency, right? When we build our application, Spring Boot will anyway look after those dependencies and configure the class path with the necessary beans that it requires. So it enables Spring Boot to, so therefore it will automatically create and register the bean based on the jar files that I've included in the class path. Now, this is reducing the need for the manual configuration. Already talked about this particular example, right? So this is the reason why we are using autoconfig. Now, how will you answer this? You will talk about all of this point, that this is the main focus of Spring Boot development, increasing the developer efficiency, because I don't have to worry about writing the data source code or writing the beans for the data source when I'm writing a simple, for example, hello world application. Okay, I don't have to worry about setting up a server on my own. So auto configuration is actually doing that for us. By help, it is allowing Spring Boot to automatically detect and configure the beans, the settings, the features, reducing the need for manual configuration. So when you add Spring Boot starter web dependency, do you have to worry about setting up anything, any line of code do you have to write to up the Tomcat server? No, you don't have to. Why? Because it is anyway coming, the Spring Boot is resolving from the jar file, it is resolving the necessary dependencies and putting it on the class path. So you don't have to worry about that. Similarly for DB, you don't have to set up any entity manager and your data source and everything which you had to do previously. So that is the beauty of using auto configuration. Okay. So the one more thing which I've highlighted over here is, remember your class, main class, the main class which is declaring this particular annotation will be considered the default. So wherever package is in that, the main class is in whichever package, that package will be scanned along with the sub packages to determine all the necessary dependencies in the beans. So that is why there only we should apply it. Otherwise, if you put it in some other in other class and you want the scanning to happen in some other, then it will be very difficult.
Next question, give very genuine and simple use cases on why someone should use Kafka. Okay, make it jargon free, easy to understand, similar to the question which we had done there. So, you see, Kafka's usage, the importance can be justified using a lot of jargons, throughput, latency, asynchronous, real time, handling large volume, all of that. You have to give when you are asked to talk about in terms of, see, this question can be asked in many different ways. You can be asked, where have you used Kafka? How does it actually help in this certain situation? Or maybe some use cases or real world scenarios where Kafka is used. So you have to be prepared for those questions instead of learning about benefits of Kafka, advantages of Kafka like that. So so let me try to give some examples which I think is relatable. So like we have given this example of a app, banking app, wherein you do some transaction and you get notified. So there are millions of transacting users. How do you think the notification happens so instantaneously? Therein, there the Kafka kicks in because it helps you with the real time processing from preventing the systems getting overloaded. If it was a synchronous mechanism, then it was impossible for you to get the message instantaneously because there's a completely separate entity which is managing the notification for you, that too in the real time. Okay, that too with low latency, that too with higher throughput. Why? Because it's a completely different architecture. It's a distributed architecture, distributed systems architecture. It has a completely different architecture, right? So now, just because it is loosely coupled, not tightly coupled to your code, if it was a normal service which was handling the notification, it wouldn't have been so fast. Because it is a completely different entity, a completely different messaging system which has its own strengths with which it has come. That is the reason why it is able to deliver the messages instantaneously or notify the users instantaneously. Then at the last you can use this term, but try to give some real use cases where millions of users, you know, even billions of transactions. Then how will your microservice be able to handle until it delegates it to completely different entity? So that is where it kicks in, right? Similarly, whenever you're interacting with any streaming apps and you see that based on whatever you do, how you interact with the app, you're getting recommendations. How do you think the recommendations are coming at the blink of your eye? Because your clickstream events are getting processed in the real time. That is business for that app. So everything you do, play, pause, skip, that is analyzed, even on your Amazon. That is analyzed and they suggest you. You may have also seen certain places, some apps where it will say that, okay, this is you have selected and this is the thing which with it can pair up really well, right? So how is this happening? Your clickstream, somebody is analyzing, then somebody is running a business logic and analyzing what will be a better fit, what will be a better thing that you would want to watch or buy or eat, and then suggest that. So how is this happening? So that is where again Kafka streams come into play because it is processing the user events in real time and low latency. Now here the low latency thing is coming. Again, your retail chain like Walmart, okay, they have multiple systems. Now there's a different use case. It has multiple different systems and it has to, aggregate all of that to understand how the business is performing. So the data will come in from various different sources to some central location. Who is that central location? Kafka it is, which is going to analyze the different data, do some business logic, and make decisions and generate reports and dashboards, and maybe help you to manage the inventory better, apply more promotions, and all of that. So now here again, Kafka is coming into picture. In food ordering app, this entire pipeline, right from your order to your to you placing the order to your restaurant, confirming the order to the delivery guy getting the notification to the finally your food coming into your home with time to time status of the delivery. Everything is happening so smoothly, so seamlessly. How? If it was a synchronized process, it would have never happened. Only because it is doing it asynchronously, without one event waiting on another, independently getting processed. So that is why I'm getting a seamless experience. So these are some of the things which you can talk of wherein Kafka plays an important role. Not just Kafka, anything. Any messaging system like Kafka plays an important role, right? So you have to understand the real time use cases, real world use cases, and then accordingly answer your question. The next question is, what is the purpose of @enable auto configuration annotation in Spring Boot, and how does Spring Boot achieve the auto configuration, and how can we exclude a dependency from this? So auto configuration is one of the most popular options. So auto configuration is one of the biggest reasons why Spring Boot has gained so much popularity. When we say sensible defaults, Spring Boot is opinionated, it is because of this particular feature. So what is actually happening when we use this annotation is we are telling Spring Boot firstly that whatever dependencies I've supplied in the pom.xml, you will scan the class path and automatically configure the required beans based on the available dependencies, so that I, as a user, as a developer, I don't have to do any manual configuration like we discussed in that previous question of Spring Boot versus Spring Framework. So that is the reason why Spring Boot will automatically configure your application based on the dependencies that you've given in your POM file, right? Instead of manually defining us. And that is how it is providing you the sensible defaults. And it also happens on a conditional basis. We'll just see this on the ID that it uses called something called conditional beans. We'll also talk about that. So if this exists, you can think of it like a if else. If this exists, then let me auto configure. If bean X exists, let me auto configure bean Y. So if it will detect that, okay, if starter JPA is there, then these are the required classes which I have to auto configure, or the components or the beans which I have to auto configure. Okay. On the context of this, one more thing I want to talk about is we independently do not nowadays use this annotation. This annotation is replaced by @Spring Boot application. This is also another question. Could be a follow-up question also. So enable auto configuration is a part of this. Initially, we used to write these three annotations separately: add configuration, add component scan, enable auto configuration. Configuration meaning that class will have all the bean marked methods or the bean definitions. Component scan meaning this class, wherever this package is, you are going to scan. I'm telling Spring Boot that you are going to scan for other components in this package and the sub packages. And enable configuration we just explained. So combining these three, now we are getting one composite annotation which will prevent us from individually mentioning these three annotations, right? So when you use this, it will implicitly anyway include this. And now because of this, you are, of course, the developer ease is there. It is developer friendly. We are able to start any new project very quickly. Writing a hello world application on Spring Boot is very quick. 5 minutes is what it is going to take. And you can, of course, override it. Now, this is how it is. And the question was how to exclude it, how to exclude a certain class that you do not want to be auto configured. This is the way. At the Spring Boot application, you're going to write like this. Okay, you can maybe give the name of the class or the fully qualified name of the class also. Now, if I go to the IDE, let me show you. This is a very simple application. I just have a controller, two different get and post mapping. And in my application properties, I have just added the debug equal to true. And on the pom.xml, I just have a Spring Boot starter, web, test, and h2. Okay. So if I run the application, the debug is true. You should be able to see how the auto configuration is actually happening. See this. Let me scroll up a little bit. There's so many auto configuration classes, and all of these are part of your spring.factories, in which all the classes are defined. It is in the meta inf folder. So if I go over here, there are something called negative matches, and there is also another positive matches. So let me say what is a negative match. It is saying conditional on class. I'll talk about conditional beans also. Conditional, if I did not find this required class, I am not going to do the auto configuration of active MQ. Or let's say if I didn't find this particular, let's say for Cassandra, auto configuration, I'm not going to do because I didn't find this particular class. So on conditional class, on conditional bean, on conditional property. So this is how internally it is going to do the resolution. But what are the positive matches? Now, if I just search for Tomcat, I see that it's a conditional on class, that if I find this class, then I'm going to do the auto configuration of this embedded web server. So the reason why the embedded web server is in place. So in my external libraries, I've located the Tomcats jar Okay, it's in org Apache Tomcat. Inside this org Apache Catalina dot startup, and then inside that I have a class called Tomcat. Because this exists, that is why the auto configuration of this class is done. Similarly, it is done for every other class based on the conditional check. So this is what is happening behind the scenes, which we do not have to worry about. Okay. Next question is list some useful features from Java 17. List some useful features from Java 17 that you may have used. Now, it is not necessary for you to have used the latest Java version, but a fair knowledge of what are the new things that are coming in along with the different Java versions is also quite necessary as a Java developer. Okay. So now let me talk about the features. So one is this text blocks thing, which was very popular. Reason being, any kind of indentation formatting, I do not have to worry about. I can just write this inside happily within a string in based on how I want to format it, and that exactly in that manner it will be printed. Very handy when we have to work with JSON. Unnecessary escape characters will be there, right? Usually. So for that, it is a very good thing. And there are two new escape characters which have been used. So you can use a slash s if you want to add a space, or a slash for removing the new line. So I can just do this like last name slash s. So I'm just basically giving a space. And if I'm doing a slash, it means I'm removing a new line. Okay, so again, for handling JSON, for writing SQL statements, although we don't write, but in case, um, it is also going to be very handy because we are using this text blocks. What is text block? These three double quotes, starting and ending. This is the text blocks. So this is one feature which is useful. Second is the helpful null pointer. Like this is a boon, like a very, very major help it is going to be for the developers, because when null pointer exception happens, we usually get a message like this: null pointer at this line number. Now at this line number, now I can understand. Most of the times, if it is a simple line of code, we can understand, but certain times we don't actually understanding why the null pointer came, which object was null, until we again do a debugging. Because if it is a simple code, we can still understand. But if it had been something like this, where it is telling me why the null pointer exception occurred, that I cannot invoke the get color because the return value of this object is null. Very, very self-explanatory. That is the reason why this particular enhancement is so very helpful, which has come in, the null pointer being descriptive. Apart from this, there are two more things which I want to talk about. Records and sealed classes. So I'm just going to give you a brief thing. You can do your homework and just do your research on that. Records, instead of us writing the boilerplate code, now forget about Lombok also. Don't have to worry about that. Just in one line, you can define your Java details. That is an improvement, enhancement which has come in. And sealed classes is for giving a very tight inheritance hierarchy, that you want only this classes to be your subclasses to control the inheritance behavior. That is also a very important enhancement. So this was just a teaser for you guys to see. I cannot spoon feed every question over here because I want to cover the breadth of the different questions and topics, right? But I'm just going to give you an idea. Now it is up to you to do dedicatedly more research on these kind of topics, like Java 17, Java 21, Java 22 is there. So all the new features that are coming in post Java 11, it is your duty to know about those features before going to a Java developer interview. So that is the reason why I've included this question. If you want me to make a dedicated video on that, that is a different thing, but not covering anything as such as part of this particular video. But please be prepared about this question. It's very important. Next question is when to use at the rate primary annotation and where to use at the rate qualifier annotation. Okay. These are used when you have multiple beans and you have to ensure that one of them only get resolved. Multiple beans of same type. So I have an interface and I have 2-3 concrete implementations. Now, which one I'm going to use when I'm auto-wiring my interface? So over here, I say that this is my default payment service. So we will be using at the rate primary when I'm saying this particular concrete implementation out of the multiple beans of this payment service. I want this one to be the preferred choice until or unless you have marked some other bean which is being set as a qualifier bean. So because of this, I am making the reducing the need of no need to specify a qualifier. Okay. So if you inject payment service without even specifying a qualifier, this will be always by default injected. I mean, this it is as simple as payment service is equal to new of default payment service. This object will be created. When to use a qualifier? When you need to specify exactly if you want to override this thing also, exactly which bean to use, which will be qualified. When you have multiple beans and want to use that one which is not marked as primary. So this gives you the control, again same which implementation will be used rather than relying on the primary bean. So qualifier gets more precedence. So over here, if I'm saying that PayPal payment service is going to be the qualifier, then that is going to get resolved in the checkout service. So as we can understand, clear cut primary will be used when you want to have a default bean. Qualifier will be used when you want an overriding thing. Instead of say primary you will use if you know that you do not know if a qualifier at all exists or nothing. I want this to be my safe choice. Qualifier is like you're very much 100% sure this only you want to be the particular bean, giving you more explicit control over the implementation. So that is the main difference between these two annotations and when to use which one. Next question, do you know about conditional annotations and give any two examples on how to use them? So we just now talked about conditional annotations, how Spring Boot uses that for resolving the dependencies while doing the auto configuration, right? So why do we need conditional? As the name suggests, I will be doing this under specific conditions, right? There are certain examples like conditional on property. If I have like a feature flag or a feature toggle, so if I have this particular property, only then I'll be using this. So enabling a feature based on a config flag, suppose you want to enable certain feature. Only on the basis of this, if this value is true, then I will be doing certain things. Okay, then I'll be ensuring this particular feature works or this particular bean is injected like that. That is one thing. Then conditional on missing bean. If this bean is missing, then I will be doing something. Like for example, if no user service is existing, then only I'll use this default user service. Something like that. So one is on property, one is on missing bean. Another we saw now also conditional on class. If this class exists, only then I'll be creating this. I'll create a bean only if a third party library like this is present, then I'll create this bean, right? So this helps you when you interact with multiple optional databases libraries, which will load beans conditionally, like what Spring Boot application context is also doing. Conditional on bean. This was conditional on class and this is on the bean. If this particular bean is already there, then if this bean is there, if you want to create a bean, if only another specific bean is there in the application context, right? So if that is loaded, then I'll load this bean. This is conditional on bean. So these are the certain annotations which you can keep in mind of. Not possible for me to collate all the conditional annotations, but just to give you a fair idea of which ones are in popular use and the ones which you should be knowing about, right? So yeah, that's about this question. Next question is, why do we need Docker in microservices? You have to answer this again in a jargon-free way. Answer this and understand this in a jargon-free way. So let's talk of scenarios. See, whenever you're trying to package your application in the form of a Docker image, you're basically trying to make it scalable, runnable on any kind of machine. That is the main intention. And it can be easily shared across different environments, right? It can run anywhere. This is how your this is how your normal Docker file will look like. A simple, let's say a simple Spring Boot jar. Just copy the jar from the target, okay, into the app folder, expose the port, and you want this to be the entry point, okay. Now here's a breakdown. You can just pause it and read about it, what we are doing over here. Now, how do we build it? We just write Docker build, then whatever name we gave over here, Spring Boot app.jar, and we'll run it. So if you do this, it will be as good as clicking the run button. Now this will start your app inside a Docker container. It will be accessible from this. So your app is running within a Docker container. You have your image also. So how it helps, why we need it. Talking in terms of scalability, like I said, you are deploying this particular jar, we always deploy one instance of a jar. But in a real world, we should not only be deploying one instance of a jar. We may need multiple instances. So that is where your scalability comes in. So when you have an image, you can scale it. You can scale it across different instances without worrying about any setup issues or dependency conflict or any kind of issues. Another thing is different programming languages can be there. I mean, different versions of a language can be there in two different microservices. One is in Java 8, another in Java 17. Now, managing these two would be very difficult if you didn't have Docker. Now, what will happen? You have two different containers, two different images running on its own independently. No worries. They will never cause any conflict. So they can run it independently. This is one thing. Second thing. Third thing is, let's say there is a bug. Now, because the images are versioned, you can roll back to the previous version of the image. In jar, maintaining that in a jar file is very difficult. So having Docker images rolling back and then again moving is very simple. The deployment is very smooth and seamless. That also you can do. CI/CD pipelines, coming to CI/CD pipelines. Now it is so very efficient for us to have a very smooth dev cycle. Just we'll have this Docker file, we'll build it, and then we'll run the test, deploy that new image. You write a one line of code, build it, deploy it, build it, deploy the Docker image. Every time you're just playing with the Docker image only. So it is making it very smooth and speeding it up. Then you have a Spring Boot inventory management service. Okay, now next is change in cloud partner. Okay, so let's say you have switched between different vendors. Because it is running inside a Docker container, your migration is just catch hold of that image and just migrate it. Your image is self-sufficient, self-contained, nothing to worry about. So these are the certain things which you have to understand why, the key important goals of microservice, CI/CD, scalability, okay, having a consistent image across different environments. Then there shouldn't be any mismatch if there is any programming. I should be able to code independently, that flexibility. So all the features that your microservice architecture requires, Docker will ensure all of this, all the boxes are checked and ticked. That is the sole reason why Docker becomes so very important in case of microservices. Next question for you is, what are stereotype annotations? Very popular question. So mainly there are 5: component, service, repository, controller, REST control. So all after component is the base stereotype annotation. Okay, the most generic. So what are these annotations? The ones which are used to define the beans in the application context. We use this annotation giving a hint that these are the ones I want to create the objects of. And we have specified the names of it such that it will indicate what work it is doing, the role of it. Okay. When I say service, I know the class's work is to only contain the business logic, nothing to do with the database, nothing to do on the HTTP request handling. So component is the most generic stereotype. So if a class is annotated with component, it automatically will become a bean and is automatically detected. So that is what we will use as a at component. So from this, spanning from this, we have others. So @ service will actually be extending the @ component annotation only. Now, when I said @ service, if I'm annotating a class with @ service, I'm telling it will hold only business logic. That's it. That is the meaning of this. And automatically, of course, the bean will be created for this as well. Repository, any DB operations, any DB manipulations, interactions which I'll be doing, that @ repository should be taken care of. That class will be marked as @ repository. And controller, like I said, especially for handling your web request and returning the responses. So that is the entry point of your code. You'll mark it as controller. Then also we have @ rest controller, which also extends this. If I show you in the ID, so let's say I go to over here and I go into @ component. If I click over here, you can see that it's written that it is a part of the stereotype annotation, if you can read from here. Now, again, if I just go back and let's say I go into @ service. So if you see, service is saying it is an alias for component.class. Okay. But if I go into REST controller, like I was saying that its annotation is it is alias for controller.class. It is a part of the controller.class. Okay. It is actually having at the rate controller. And your service will have at the rate component. This is how it is. So now we'll start wrapping up. So this is the second last question. What is the difference when to use at the rate bean and when to use at the rate component? So we just now discussed about at the rate component being the stereotype annotation. So for any class for which you want the objects to be created or the beans to be created and to be also auto-detected while doing the component scan by the Spring application context. Those classes you're going to mark it as component. At the rate component again being generic. If you have specific use case, it can be at the rate service, repository, controller. But sometimes it doesn't fall under any of the cases, but we just want to mark it as a component for for which we want the beans to be automatically created for that particular class. So for that, we will use at the rate component because it is working on a class level. It is a class level annotation. Now, bean is a method level annotation. The point is same, that classes beans will be created, and here for the single explicit declaration, like we are declaring that particular method on which we have put at the rate bean, we want that method, the return value of that method to be a bean. Okay, so that will give us more control. Like for data source beans, we use at the rate bean. So it can create the beans for cluster outside Spring context, and it will decouple the bean. So there, it is not tightly coupled anywhere that if I create put at the rate annotation on this class object. Usually for third party libraries on which we cannot append, I mean to which we cannot add the at the rate component annotation, but we want the object to be manipulated or returned otherwise by doing some configuration for that object, we will use at the rate bean. So as we can see here, we are using at the rate component on this service, right? But bean, we are saying that whatever is the return value of this return value, I want this object, that return value to be treated as a bean. And in component, it is like one bean, one class. It is working on the class level. Attribute bean is working on the method level. That is the biggest difference. When to use which one? As I said, you want Spring to configure that class entirely as a bean. Then you will use at that component. When you want that classes, when we do at auto-wire on that, we want that entire class to be returned. When we'll do auto-wire, we want that entire class to be returned, like all the the object of the class to be returned as a bean. But when we manipulate, we want to manipulate the return value of the object of a certain class in a certain way, then only we will use at the rate bean, right? So you can think of some third party service was there. Now based on some conditions, some business logic, I am saying I'm going to return different implementation. I don't want to go with the default implementation which is returned. So then you should be using at the rate bean. I hope the difference is clear. Compare and contrast microservices with serverless architecture. So briefly, we'll talk over this topic because sometimes you may be asked when would you want to use serverless and when would you want to use microservice. So let's talk about that. So microservice, we already know, loosely coupled. You want independent services with different programming language, self-contained, all the things that we already know, right? And this is giving more flexibility, technology choice. So we know this. Now, what is serverless? Serverless, as the name suggests, you do not have to worry about any server deployment or server infrastructure. Just focus on your writing the business logic, your code. Don't have to worry about managing the servers. So that is why we see serverless. And it also operates on the pay as you go model. So how much time your code is running, on the basis of that, you will be actually paying for the resources. And also they can be event driven and stateless. So basically based on certain event, I want the underlying code to run, that can happen. And event driven, real time, short lived. So that is what we will use serverless for. So it depends on the use case. Even there can be multiple microservices being deployed as serverless functions. That is also possible, right? So just a very brief overview on what is this microservices and just contrasting it with serverless so that you can understand that there are different architectures which is present in our industry, and you may be asked questions on them. So not very detailed, but like having a good overview, a good understanding of every type of architecture is also very important so that you can answer the questions accordingly. The main points, just remember the keywords of each architecture, right? uh, yeah, so that is about this. I think We have already covered more than 45 minutes. So I hope you guys are getting some value out of it. If you are, please continue watching the series. You can try to binge watch the series, one, two, three, like that. Or maybe you can watch it as for your convenience, whatever works. But please ensure that you are actually following the things and revising it also from time to time. Thank you so much again for watching, and please like and share this video and subscribe to the channel if you haven't already. Thank you so much.